All right, guys, here's my first attempt in a video to help you out with the Eureka Module 4 Math. My first sheet of paper here, I have some notes about equations and tips for this module that I think might be beneficial for you, so I'm going to go through those first. The first thing I want to remind you is that the mathematical definition of slope is the steepness of a line, and we talked about that in class. And remember, when you look at the graph, you need to look at the graph from left side of the graph to the right side, just like you do when you read a book. That will give you a frame of reference for determining if the line is rising, going up from the left to the right, like when you're climbing up a mountain, or whether the line is going downhill from left to right, like if you're going down a roller coaster, period. So that's really important for you. Now, I have below that, just a reminder for the slope formula, which I'm showing to you right now. And for slope, we always use the letter M in the alphabet to represent the word slope. And the formula you want to use is M is equal to y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. And remember that your x sub 1, y sub 1, and your x sub 2, comma, y sub 2, that just is representing 0.1 on your graph and 0.2 on your graph. So it's just a way to identify the numbers, so you sub them into the formula in the correct order. Also, one of the forms of the equation you need to be familiar with is what they call the slope-intercept form of the equation, which I have written next, and that states y is equal to mx plus b. And m represents the slope, the numeric value of the slope, and you always want to try to write that as a fraction because we want to see what the vertical change is compared to the horizontal change. The b in that formula, that's what we refer to as the y-intercept. And remember, the y-intercept is just the point on the y-axis where the graph, that line, crosses the y-axis, and that'll be a numeric value also that you'll sub in for that. Okay. So now I just flipped over to my second page of notes for you, and I drew you a picture of what is called the coordinate plane. And you see an XY axis there, and that X and Y axis, that is the coordinate plane, that point of intersection where I have labeled 0, 0, that's called the origin. And then I have the 4 quadrants labeled there for you. Quadrant 1 is the top right quadrant, quadrant 2 is the top left quadrant, quadrant 3 is the bottom left quadrant, and quadrant 4 is the bottom right quadrant. Then finally, I write down another form of the equation of a line that you're going to be familiar with, and that's what we call the point slope form. And that form looks like this, where we have y minus y sub 1 equals m parentheses x minus x sub 1, close your parentheses. And again, the x sub 1, the y sub 1, that's the point on the line. You'll have a number for x sub 1 and a number for y sub 1. M is your slope, and the x and the y in that equation, those are variables that you never replace with numbers. You just simply leave those in your formula there, all right? Finally, then at the bottom there, I have another form of an equation that's called the standard form of an equation, and that states ax plus by equals c. And really, when you write it in that form, you're just making sure that you have your x variable and your y variable on the same side of the equation. The c is your constant term. That's the term that just has a number with it without any variable attached to it. And it's good practice to have the coefficients on x be whole numbers. So if you have a fractional coefficient there on that x variable, you kind of want to just clear it out by multiplying the whole equation by the denominator of that fraction. Okay, that's the end of my first video. I'm going to stop it now, and then my next video will be an example for problem number 1 that I assigned for this week of April 20th through May 1st. Thanks, guys.